Question 1 says solve the system of equations by the elimination method. The elimination method, also known as the addition method. In elimination method, we are adding the equations or some copy of the equations together to eliminate one of the variables, x here, x or y. So if we look at this equation in its current form, we can see that if we added these equations, x and a negative x would cancel. In other words, we could eliminate the x's just the way they are by adding these equations together. So we're just going to add these equations together in their current form. X plus a minus x would give us no x's there. X plus y would give us 2 y's. And on the other side, we have 27 plus 5 giving us 32. Okay, so this method, basically we're trying to eliminate a variable, so we just have an equation with one variable, and then if we have an equation with one variable, it should be easy to solve for that variable. So here we can see we would just need to divide by 2 now, because that's 2 times y. And so when we divide 2y by 2, we just get y, and 32 divided by 2 is 16. So now we have an answer for y. Y is 16. So now we can go back to one of our original equations and take this value 16 for y and plug it in to help us get our answer for x. So if we look at the first equation, and we have x plus y equals 27, and we already know, like we said, that y is 16, so this really becomes x plus 16. In other words, we're taking that y is 16 and plugging in the 16 for y there. And so x plus 16 is 27. Now we need to just subtract 16 to figure out what x is. So we do that to both sides. We get that x equals 11. And so we have the answer x equals 11, y equals 16. This question says find the value for x. And so if we look on the answer choices, we see that x equals 11. That would be answer choice E. Question 2, solve this system of equations by the elimination method. And so here we see that if I add these together, we would get 5x minus 2x would be 3x. So it doesn't eliminate the x's. Negative 2y plus y would still give us a negative 1y or a negative y. So just in the current form, neither of these would eliminate. So we want to find, choose one of the variables that's easy to get a common multiple that we could then eliminate that variable. So if we look here, a common multiple for the x coefficients, 5 and 2, would be 10. So I'd need to change them into 10 and minus 10. So I'd have to multiply both equations here. Common multiple of 2, and this would be 1y, would be 2. So I would only need to multiply the bottom equation. So I'm going to choose to eliminate the y's here, and I'm going to multiply the bottom equation by 2. And that would give me a minus 2y and a plus 2y, which would then eliminate the y's. So multiplying that equation by 2, writing it down here. So we're going to get a 2 times a negative 2x would give me minus 4x. 2 times a plus y would give me plus 2y, equals 3 times 2 is 6. We want to make sure we multiply the entire equation. And I'm just going to copy down my first equation here. So 5x minus 2y equals negative 8. Okay, so now that we have them with a minus 2y and a plus 2y, we can see when we add these together, we're not going to have any y's. So we have eliminated our y's. So 5x minus 4x gives us 1x, or just x. Again, no y's left there. And equals negative 8 plus 6 gives us negative 2. So pretty easy there, kind of solved itself for x. So we have x equals negative 2 already. And now we want to use that and plug it back into one of the other equations and find y. So we'll just use maybe our first equation here. So let's write that down. So 5x minus 2y equals negative 8. And then x is negative 2, so I'm going to make this 5 times negative 2 minus 2y equals negative 8. 5 times negative 2 is negative 10 minus 2y equals negative 8. And then here we need to get the y term by itself, so we'll add 10 to both sides. Adding dividing 10 would give us that negative 2y equals negative 8 plus 10 would be a positive 2 there. Dividing by negative 2 on both sides, it's going to eliminate that, so we're going to get y equals, and a positive 2 divided by a negative 2 would be negative 1. And so the question says find the value for y. Y is negative 1, and that corresponds with answer choice D. Question 3, solve the equations by the substitution method. Find the value for x. So substitution method, what we want to do is we want to find what one of the variables is equal to, and then we can use that information and make a substitution with that information. So I'm just going to take the first equation here, and I'm going to create a substitution by solving for one of the variables. And if you look at this equation, x minus 4y, I think it's easier to solve for x here because we would just need to get rid of this minus 4y term. If we were trying to solve for y, we'd need to move the x and also divide by negative 4. So we're just going to create a substitution by solving for x. I'm going to take this first equation here, x minus 4y equals negative 10. And I can solve this equation for x by just adding 4y to both sides. So here then we get x is equal to 4y minus 10. Okay, so I have what x is equal to. X is equal to this expression here, 4y minus 10. So this is now our x substitution. And we want to take that information and place it in the other equation where x is. So now we're going to be using this equation here. We have x plus 3y equals 11, looking at the other equation. And we know what x is. X is 4y minus 10. So I'm going to be, in place of my x, I'm going to be putting 4y minus 10. That's what we're going to have there. So in place of x, we have substituted for x this expression over here. 4y minus 10. Now we have plus 3y equals 11. We always want to make sure we copy down the rest of the equation there. And so now we simplify. 4y plus 3y would give us 7y minus 10 equals 11. And now we just solve for y. You can see that that substitution allowed us to just have an equation with one variable in it now. So we're going to add 10 to both sides, and we get that 7y equals 21. And if we divide both sides by 7, then we should get that y is equal to 21 divided by 7 is 3. Okay, so we have an answer for y. And now, since we have our answer for y, we can use our answer to get the other answer. So if y is 3, then going back to this equation here, which is already solved for x, so I think this is the easiest one to use. X is already by itself. So x then equals 4 times y, and we said y was 3, minus 10. So x equals, here we have 12 minus 10, and so x here is equal to 2. And this particular question is saying find the value for x, so this is the actual answer they want us to give, and x equals 2, that is answer choice B. Question 4, we have a word problem. It says two numbers have a sum of 34. One number is 8 more than the other, and we're asked to find the larger number here. Alright, so two numbers have a sum of 34, so I'm going to call my numbers, I'm going to call the first one x, and I'm going to call the second one y. Okay, and it says two numbers have a sum of 34. Sum meaning we're adding, so these two numbers have a sum, meaning if I add them up, I should get 34. Alright, one number is 8 more than the other. Alright, so one number is 8 more than the other, so maybe I'll choose this to be my one number. So one number, I called it x, is, we always want to remember in word problems that usually is going to refer to equals. So one number is x equals 8 more than. 8 more than means we're going to be adding 8 to something. So I'm going to put a plus 8 here. 8 more than the other, and so I guess the other number would be y. So we have our two equations here. Again, this first equation, two numbers have a sum of 34. Our first sentence gives the first equation. Second sentence, one number is 8 more than the other. So here, one number x is 8 more than y, in other words, y plus 8. Alright, so now this system of equations with two variables is actually set up. Here, this second equation, we have an x substitution. In other words, x is the same as y plus 8 here. Okay, so we can use that x substitution in the other equation. So here we have x plus y equals 34. And I'm going to use my x substitution now. So in other words, where x is, I should be able to put my y plus 8. So y plus 8 plus y equals 34. And now we just do some combining and solving. So y plus y is going to give us 2y plus 8 equals 34. So here we need to now subtract 8 from both sides. Alright, and let's continue that up over here in the next column. So once I subtract 8 from the left side, I'm just going to have a 2y there. And when we subtract 8 from the right side, we're going to get 26. And then we divide by 2 to solve for y, because we have 2y. And so y equals 26 divided by 2 is 13. So we have y equals 13. We need to go back and find x. So let's just go ahead and use our x substitution equation. I'll use this one right here. So we said x is equal to y plus 8. And we already found y. We know that y is 13. So I'm going to use 13 instead of y, and that's going to help us solve easily for x. X is 13 plus 8 now, so x is 21. So we have x is 21, we have y is 13. The question says ultimately they want us to find the larger number here. So between 21 and 13, x is the larger number. So x is 21, and that is answer choice E. Question 5 says, solve the system of equations by the substitution method, and we want to find the value for x. Alright, so here we look at both equations and we want to choose the one that's easiest to get a substitution. Here I have a variable by itself, x, and so that would make it easy to solve this equation for x. So let's go ahead and build our substitution off of this equation. So think about if we subtract 2y from both sides of this bottom equation here, then that's going to give us the equation x equals, and then we would have negative 2y minus 2. And so this would be our substitution that we can use. So x is the same as negative 2y minus 2, and so we can take that information and then put it into our other equation. So that's going to get us, let's start over here, so we have negative 4. Now because we're going to have negative 4 times x, it becomes negative 4 times all of this that x is over here. X is negative 2y minus 2. It's a good idea to put that in parentheses so that when we distribute, we make sure that we don't make any sign errors there. So that's going to be negative 4. This is the same as x. And then we continue on, minus 8y equals 5. So now we have to distribute our negative 4. Negative 4 times negative 2y. 4 times 2 is 8. A negative times a negative gives us a positive, 8y. And then the same thing here. 4 times 2 would give us 8. And negative times a negative makes that a plus 8. And here we get a minus 8y. And that equals 5. Alright, so now we need to simplify. We can combine here. We get 8y minus 8y. That gives us no y's. The y's cancel out there. So we get 8 equals 5. So this is one of our special case equations where the variables cancel out and we just get a number equals a number. So we look here and we see 8 equals 5. A good thing to ask ourselves then is, a question. Is this an equation that is always true? Or is this an equation that is never true? Okay, so we ask ourselves that. Is it always true or never true? Well, 8 is never equal to 5, so we definitely get the case that this is never true. If this is never true, then that means the lines that represent these equations, if we graph them, these lines never touch each other, meaning that these lines run parallel to each other and never intersect. So we say that the lines are parallel, because they never intersect each other. Or we say that there is no solution, because the solution is whenever the lines would cross each other. So parallel or no solution, and that is answer choice E. Question 6 says solve the system of equations by the elimination method, and we're going to be finding the value for y. So if we look here, we want to see which variable is going to be easier to eliminate, and looking at the common multiples. So thinking of x, least common multiple of 2 and 5 would be 10, so we would need to multiply both equations to get 10 and minus 10. Here, least common multiple of 3 and 6 is actually 6, so I think y is going to be easier to eliminate here. We have a plus 6y, so here we would need a minus 6y, which means we would just need to multiply the bottom equation, and to get a minus 6y, we would need to multiply the bottom equation by negative 2. Alright, so let's go ahead and do that. So our bottom equation is going to become negative 2 times 2x, so we get negative 4x, negative 2 times 3y, minus 6y, equals negative 2 times negative 6 is positive 12. And let's just copy down our first equation, so 5x plus 6y equals negative 14. And now we add these together, we can see our y's are going to eliminate or cancel. 5x minus 4x just gives us 1x, or x. And negative 14 plus 12 is going to give us negative 2. So there x equals negative 2. And now we want to then complete solving, so we need to solve for y. Let's take that, we'll just plug it back into, let's say, the first equation here. So using, again, 5x plus 6y. Again, we're using our answer for x to solve for y. So x is negative 2. Using that information, we'll put in negative 2 for x. So we have 5 times negative 2 plus 6y equals negative 14. 5 times negative 2 is negative 10 plus 6y equals negative 14. Here we need to get rid of the negative 10, so we'll add 10 to both sides. Adding 10 to both sides will give us that 6y equals negative 4. And I'll complete my equation over here. So 6y equals negative 4. We would need to divide both sides by 6. So it looks like y is going to equal negative 4/6. And both of those are even numbers, so we can actually reduce that. So we're going to get y is equal to, if I divide both by 2, I get a negative 2 on the top, and I get a 3 on the bottom. So y is equal to negative 2/3. And it said find the value for y, so y equals negative 2/3 is our answer, and that is answer choice B. Question 7 is a word problem. Joe has $1.90 in dimes and quarters. He has a total of 10 coins, and we're looking for how many quarters he has. So when we have a coin problem, I think the best way to set it up are two equations. To think of one equation, we want to think of our first equation as just our basic total equation. In other words, what do we have and what is the total of what we have. So we know we have dimes and quarters here. Okay, and just to make it easy to see what's going on here, I'm going to then call my variables D for dimes and Q for quarters. So we know that we have dimes and quarters, and the total number of coins we have is 10. So I guess the number of dimes plus the number of quarters has to equal 10, because that's how many coins we have. The next equation you can think of as your value equation. What we're going to do is attach the value of each thing to that thing and sort of see what we have. So the value for dimes, what we have is 10 cents per dime, right? Every dime is worth 10 cents. So we're going to say 0.10, okay, 10 cents for every dime that we're holding. And then we're also going to add the value of quarters is 25 cents, so 0.25. So we have 25 cents for every quarter that we have, so 0.25 times Q. And then the total value of the 10 coins is $1.90. So we have $1.90. I'm just going to write it as a decimal and leave my dollar sign off. Okay, so we have two equations here. Here the total equation. The total of dimes and quarters is 10. Here the value, 10 cents per dime we have, plus 25 cents per quarter we have, is going to give us $1.90. That's our total. And so now we just want to solve this system of equations, either using substitution or elimination. I'm going to go ahead and use elimination to do this one here. So if I look at this equation, the first thing I want to do is I'm going to eliminate my decimals here in this equation, and I'm going to do that by multiplying this by 100. And the reason is because we have two decimal places. Multiplying by 100 will move the decimal over 2 to the right for each of these terms, so I'm going to multiply by 100. So that is going to give me, so moving this over 2, we would get 10 times d, plus moving this over 2 would give us 25 times q, and moving this last one over 2 would give us 190. And I'll copy down my first equation, d plus q equals 10. Okay, so now to eliminate, here we would need to then either eliminate the d's or the q's, the dimes or the quarters. Since d has a smaller number here, 10, I'm going to clear the dimes instead of the quarters. Here I'd have to multiply by a negative 25 if I wanted to eliminate the quarters. Here I just have to multiply by a negative 10, which is easier. So I'm going to multiply this equation by negative 10, allowing us to eliminate. I'm just going to go ahead and write that underneath here, directly underneath. So we'd get a negative 10d minus 10q, give us negative 10 times 10, negative 100. And then when we add those together, 10d minus d is nothing, no d's. 25q minus 10q gives us 15q, equals 190 minus 100, so that's 90. And then when we divide by 15 on both sides, we get that q equals 90 divided by 15, which is 6. And the question is asking how many quarters does he have, and we've already found q equals 6, so that should be our answer there, that the number of quarters is 6, and that is answer choice B. Question 8, solve the system of equations by the substitution method, and we're going to be finding the value for y. So when we look at these two equations here, we can see that the second one is set up as a substitution. Here we have a substitution for y. This is saying y equals negative 2x minus 26. So we can use that information as a y substitution and just substitute into the other equation directly. So right off the bat we have in our first equation 3x minus, now we're going to use this y substitution. It's more than one term, so to avoid making any sign mistakes I'm going to plug it in parentheses. So y is negative 2x minus 26, that's what y becomes in our first equation, and that equals negative 14. So in other words, where y used to be here, we are now taking that information and plugging it in for y. Okay, so now we need to, let's distribute our subtraction, or our minus here. So 3x minus negative 2x would be like plus 2x. Minus negative 26 would be like a plus 26. And now we'll combine our like terms, so 3x plus 2x there is going to give us 5x. Plus 26 equals negative 14. Okay, here we just want to solve for x, so we'll subtract 26 from both sides. So on the left we just are left with 5x equals negative 14 minus 26 is a negative 40. And now to solve for x we need to divide by 5, since that's 5 times x. And so we're left with x equals 40 divided by 5 would be 8, and since it's a negative divided by a positive, we get a negative 8 there. And so now let's look back at our substitution equation. We should be able to figure out what y is. So we said y was equal to this equation right here, so negative 2x minus 26. And we know x is negative 8 already, so we'll just take that information and put it in for x. So negative 2 times x becomes negative 2 times negative 8 minus 26. Y equals negative 2 times negative 8 would become a positive 16 minus 26, and 16 minus 26 is a negative 10. We're subtracting a bigger number there. Alright, so the question says find the value for y, and so y equals negative 10, and that is answer choice D. Question 9, we're solving this system of equations by substitution method, and we're finding the value of x for our answer. So looking at these two equations, we should be able to see that the first equation here is actually already set up as a substitution. We have a substitution for x. X is the same as y minus 10. So right away we can use that information in our second equation. So we have negative 3x for our second equation plus y equals 18. We already know what x is from our x substitution up here. And so that means negative 3 times x. I'm going to plug in y minus 10 for x. That's what our top equation tells us here. X is y minus 10. Plus y equals 18. And now we need to distribute. Negative 3 times y gives us negative 3y. Negative 3 times negative 10 is a plus 30 there. Plus y equals 18. Alright, combining our y's, negative 3y and plus 1y is going to give us a negative 2y plus 30 equals 18. Alright, let's continue over here. If we subtract 30 from both sides, alright, so the plus 30 is going to go away. We're just left with negative 2y on the left side, 18 minus 30 here on the other side. 18 minus 30 would be negative 12. And now to solve for y, we need to divide by negative 2. Alright, so we have y left on the left side. 12 divided by 2 is 6. Negative divided by a negative, same sign, makes this a positive 6. So y is 6, and now it says we want to find the value for x here. So we'll go back and figure out what x is, and we'll just use our first equation here because it's already solved for x. That's easiest to use. So x equals y minus 10. Y is 6, so 6 minus 10. And x equals 6 minus 10. 6 minus 10 is negative 4. And it says find the value for x, so x equals negative 4. And that corresponds to answer choice D. Question 10 is a word problem. Says the difference of two positive numbers is 13. The larger is 3 more than twice the smallest, and we're finding the larger number for our answer here. Okay, when we have the difference of two numbers, then that's going to be subtraction. Difference is subtraction. So we're going to be subtracting two numbers, to give us 13. So maybe I'll call my numbers x and y. So in other words, I have the difference of two numbers, x minus y, equals 13. All right. Now they start referring to the larger number and the smaller number. With subtraction, we want to make sure that we understand for this type of problem, if I'm subtracting two positive numbers to get a positive 13, which of these numbers would have to be larger? Well, think about, just for instance, let's say our numbers were 15 and 2, which they probably aren't for this, but let's just say they were 15 and 2. So 15 minus 2 would give us 13, but 2 minus 15 would give us a negative 13. So if we're subtracting two positive numbers to give us a positive number, that means that the first one must be the bigger number. If the first one was the smaller number, we were subtracting more than that smaller number, we would end up with a negative 13 there. So we want to make sure that we think about that, especially whenever we have subtraction. We want to look at sort of making a note here. X is going to be the larger number, and y is going to be the smaller number in order to give us a positive 13 there. Okay, so now we can kind of go on with the next sentence. So it says the larger is, so we look at what we made here, and that really helps us out. The larger, so we said larger was x, is means equals 3 more than. So I stop right there and I say, well, I'm going to be adding 3 to something. 3 more than means add 3. And then the rest of the sentence says twice the smallest. So twice the smaller one would be 2y. Twice the smaller would be 2y. Okay? So again, let's read back over it. The larger x is equals 3 more than twice the smallest, or 2y plus 3, adding 3 to 2y. So here we have our two equations, and we can see that this second equation here is going to be, it's already set up as an x substitution. We have x equals this statement over here, 2y plus 3. So I could use this as an x substitution, take what x is, and plug it in the other equation where x is. And that would help us solve for y. Okay, so let's do that. So our x minus y equals 13 then would become, if x is 2y plus 3, what we have here in our substitution. So this is 2y plus 3, x becomes that, minus y equals 13. Alright, now let's simplify our left side. 2y minus y is just going to give us y. And we have a plus 3 still, equals 13. And we can probably see it already, but let's subtract 3 from both sides. And that gives us that y equals 10. Alright, now let's look up here. Find the larger number. We said y was the smaller number, so we really need x for our answer. We have y, we don't have x yet. Okay, so let's just go back and maybe we'll look at this equation here and plug in our answer for y, which will help us get x. So we're going to use our answer to get the other answer. X equals 2y plus 3. And we already know what y is. Y is 10. So 2 times 10 would be 20. And 20 plus 3 would give us that x equals 23. That is the larger number. So x equals 23. 23 is the larger number. And we look at the answer choices, and they have ranges of things here, and we see that answer choice C has the larger number is between 20 and 25. 23 is between 20 and 25, so C is our answer there. Question 11, we have a word problem. Mr. Robinson has $5,000 to invest. He invests part at 3%, and the rest is at 7%. And they tell us he earns $310 in interest from the two accounts. And we want to know how much he invested at 3%. Alright, so just like the coin problem, we want to look at our first equation involving the total of what we have. here. And then we also want to look at something relating to the interest that we have. That's going to be our other equation. Okay, so if we look at, and maybe we can sort of set this up as a table first and then generate an equation. So we're going to we have three different things going on. We have part of it's being invested at 3% interest, and some of it's being invested at 7% interest. And then we also want to consider the total, because it also talks about the total. Okay, so if we look at that, then we see, let's start from the beginning and reading. So Mr. Robinson has a total of $5,000 to invest. So the total invested, we know, is $5,000. And he invests part at 3% and 7%, so obviously that gives us our different accounts here. And so maybe we'll just go ahead and call the amount in the 3% and the 7% our variables. So maybe we call this X and call the amount in this account Y. Okay, so we have X dollars plus Y dollars giving us $5,000, which makes sense. The total invested was $5,000. All right, and so the interest earned was $310. He earns $310 in interest in both accounts after a year, so that is our total interest. So the total interest there is $310. And now we need to sort of develop some expressions for how much interest we're getting from each one. That'll help us out here to solve this. So if we have X dollars in this account, and this account is earning 3% interest, then we are earning 3% interest, which as a decimal we know 3% is 0.03. So we're earning 3% on X amount of dollars, right? So the way the bank would calculate that interest, we're earning 3% on X dollars, so 0.03 times X. Over here, same kind of thing here, we're earning 7% interest, so 7% as a number or as a decimal is 0.07, and we are earning that on Y amount of dollars, because that's how much we have in that account there. Okay, so this gives us two equations. The top equation tells us that X plus Y, in other words, the amount in each account, if we add them up, we invested a total of $5,000, or Mr. Robinson did. And then the second equation tells us that 3% times our X amount of dollars plus 7% times our Y amount of dollars is going to give us 310. And so we can just simply solve this now by using substitution or elimination. I'm going to scroll here so we have a little bit more room. All right, let's go ahead and maybe we'll clear the decimals in this second equation. So we have two decimal places over here in the X and Y terms, so let's go ahead and multiply each of those terms by 100. And let's write it down here. So here we're going to get, if I multiply the first term by 100, we'll get 3X. Multiplying the second term by 100, we'll get 7Y. Don't forget to multiply this 310 by 100, so we get 31,000. Multiplying by 100, we'll add 2 zeros. Okay, so I'll copy down our first equation here. X plus Y equals 5,000. And we'll draw a little line there so we know where we are. Okay, so now we have these two equations. And we could solve this by elimination if we wanted to. Looking at this, the smaller numbers to deal with would be the x's. So I already have a positive 3x. I could eliminate the x's if I had a negative 3x on top. So to get a negative 3x on top, I would need to multiply the top equation by negative 3. And let's do that and write it underneath. And so negative 3 times x gives us minus 3x. Negative 3 times y gives us minus 3y. And negative 3 times 5,000 gives us negative 15,000. Okay, so now these are our two equations we're working with down here, and so let's add those together. So here 3x minus 3x cancels. 7y minus 3y gives us 4y. And 31,000 minus 15,000 gives us 16,000. Okay, let's continue up here and we'll solve for y. So we have that 4y equals 16,000. And dividing by 4 to get us just y. Dividing 4 both sides, we get y equals 16,000 divided by 4 is 4,000. Alright, and so now we want to find x. And we can just go back to our easiest equation here, x plus y equals 5,000. Since we already know y, we should be able to solve that for x. So x plus y equals 5,000 becomes x plus 4,000 equals 5,000 because y equals 4,000. And then subtracting 4,000 from both sides, we are going to get that x on the left side equals 5,000 minus 4,000, which is 1,000. Okay, and so now we look back at our problem here. The question said, how much did he invest at 3%? And the variable that we assigned to our 3% account was x, so that means x is the amount of dollars we have in the 3% account. And down here we can see that x is 1,000. So 1,000 is the amount that was invested in that account, and that is answer choice A. Question 12 wants us to solve the system of equations by the substitution method. So here we can see the second equation is already set up as a y substitution. We have y equals 5x plus 5. So in the other equation, we're going to take 5x plus 5 and put it in where y is, since they're equal to each other. Alright, so let's do that. We'll write down over here, our first equation is 5x minus y equals negative 5. And so if we're plugging this 5x plus 5 in where y is, that's going to give us 5x minus, and my y is the expression 5x plus 5. Equals a negative 5. Alright, and so now we have everything in terms of x, and we can solve for x. So here we get, let's go ahead and distribute our minus. We get 5x minus 5x, and then minus, our positive 5 is going to give us negative 5 there, equals negative 5. Alright, simplifying our like terms, 5x minus 5x. So our x's actually cancel out here. We're just left with negative 5 on the other side. And so we have negative 5 equals negative 5. So this is very much like question number 5 on the test, where we had our variables canceled out and now we just have a number equals a number. So again, we want to look and ask ourselves, it's one of two things. Is this a statement that is always true? Or is this a statement that is never true? And so looking at this here, negative 5 equals negative 5. Yeah, that's always true. It's always true. So if we were thinking about the graphs of the line of each equation here, these lines are always intersecting. They're always touching each other, basically. And so what that means is if two lines are always touching, or they're always intersecting, that means that they really lie on top of each other there. They basically are in the same place, both lines are. And another way to say that is to say that the lines coincide. Coincide means exist in the exact same place. And so you can see, remember, whenever we graph lines, the answer to the system is anywhere the lines intersect, but we said these lines are always intersecting. In other words, every point on one line is intersecting every point on the other line because they're the same line. So every point on the line is a solution, and so another way we could say that is, well, we don't just have one solution, we have infinitely many solutions, because we could pick any point on the line and that would be a solution. So we could either say that our lines coincide, or we could say that we have infinitely many solutions. And that is answer choice D. Question 13, solve the system of equations by the elimination method. So looking here, we either want to eliminate our x's or eliminate our y's. Looking here, I see it would be easier to get least common multiple for the y's, because this is really like having one y here. And so 1 actually goes into 4. It's easier to get a common multiple with the y's. So I already have a plus 4y. So to get a minus 4y at the bottom equation, I could multiply by negative 4. Let's do that and write it down here. So bottom equation times negative 4 would give us negative 20x. Negative 4 times a plus y would give us minus 4y. And negative 4 times 13 gives us negative 52. Alright, let's copy down our other equation. The top equation was 3x plus 4y equals 1. And now here we can see our y's are going to cancel. And we get 3x minus 20x is going to be a negative 17x. Equals 1 plus a negative 52 would give us negative 51. And we'll divide by the negative 17. Divide by negative 17. So here we get x equals 51 divided by 17 is 3. And these are the same sign, so it's a positive 3. And now I'll go back and find my y. So 3x plus 4y equals 1. And so we know that x is 3, so this becomes 3x becomes 3 times 3. Plus 4y equals 1. 3 times 3 is 9, so 9 plus 4y equals 1. And then we subtract 9 from both sides. So here we get 4y equals negative 8. And then if we divide both sides by 4 here, we're going to get y. And negative 8 divided by 4, opposite signs would give us a negative, and 8 divided by 4 is 2. And so it says find the value for y. Y is negative 2, and so that would mean that our answer choice for this one is C. Question 14 says which system of equations goes with the graph? So here we want to look at each individual line and also look at their common solution, which is 2, 2. We'll look at that last. Let's look at some equations for these lines first. Let's look at this bluish line here. So you can see we want to get some sort of an equation for the blue line. So our blue line, let's look at a couple things. So first we can look at the y-intercept. So our y-intercept is going to be, let's count up here, 1, 2, 3, 4, 5, looks like 6. The y-intercept is 6. And our slope for the blue line, if we look at, so from our y-intercept, where it crosses the grid next, it looks like it crosses the grid next at this point here. So in other words, between our y-intercept and this point here, we have a rise of negative 2. And our run is just over 1 unit, so negative 2 over 1. And so that gives us a slope of negative 2. Okay, so we have that. So if we write that in slope-intercept form, the blue line's equation should be y equals negative 2x plus 6, a slope of negative 2 and a y-intercept of positive 6. If we look at the red line, let's take a look at that now. So looking at the red line, it's y-intercept. We want to figure that out. So from the origin, we count down 1, 2, 3, 4. So we can see the y-intercept looks like it's negative 4 there. Intercept's at negative 4. And now we want to find a point where we can find the slope. It looks like it crosses, the first place it crosses a corner on the grid is this point here. And so now figuring out our slope from there, from our y-intercept, our rise would be up 1, 2, 3. So our rise is 3, that's our numerator of the slope. And then over just 1 unit is going to give us a run of 1. And 3 over 1 is the same as 3, so our slope there is 3. So in slope-intercept form, the equation for the red line would be y equals 3x minus 4, because we have a slope of 3 and a y-intercept of negative 4. As we look at the answer choices, we can see that some of the answer choices are written in standard form, and some of them are written in the slope-intercept form. So as we look down here, let's maybe convert the blue equation. Let's convert the blue equation to standard form. So if we were going to convert this to standard form, meaning we need all of the x's and y's on one side, if we added 2x to both sides, we would get that the blue line has an equation in standard form of 2x plus y equals 6. And then if we wanted to convert the red equation to standard form, so here we have y equals 3x minus 4. We would need to get our x over to the other side, so we would need to subtract 3x from both sides. That would give us a negative 3x plus y equals negative 4. Except now we want to be careful here. A little reminder, in standard form we never want the x coefficient to be negative. We always want the standard form to start with a positive amount of x. So what we would need to do is we would need to divide both sides by negative 1 in order to change the sign there. And so our red equation actually in standard form would be 3x minus y equals a positive 4. Okay, so blue, go ahead and, so our blue equation either has to be y equals negative 2x plus 6 or 2x plus y equals 6. And our red equation either has to be y equals 3x minus 4 or 3x minus y equals 4. So we look at answer choice A, we see that the red equation would give us the top one, but if we look at the bottom equation for A, we would see that the blue equation would have the wrong sign for negative 2x, so it's not answer choice A. Let's go ahead and say it's not answer choice A. For answer choice B, we have 3x plus y equals 4, and that does not match our standard form down here, 3x minus y equals 4, so our answer choice is not B. Looking at C, 3x minus y equals 4, we do have that for the red equation, that's the same as this here. And then the next equation is in slope-intercept form, y equals negative 2x plus 6, which is what we have for our blue equation here. So it looks like answer choice C has a correct option for each of the lines, the blue and the red line. Question 15 says, which system of equations goes with the graph? And so we want to look at our options and our equations for each line. So we have a blue line again, and we have a red line here. So let's look at the equation for the blue line. So equation for the blue line. Well, we noticed that the blue line is a horizontal line, and these are actually both special cases. Horizontal lines and vertical lines in the plane are special because they're only going to have one variable in their equations. And so when we look at the blue line to figure out which variable is in the equation, we want to ask ourselves, which axis does the blue line cross? And we see that it crosses the y-axis. So that means that equation is going to have y only in its equation. And now we just see where it crosses y. And as we count up from the origin, 1, 2, 3, 4, we can see that it crosses the y-axis at 4. So the equation for the blue line is just going to be y equals 4. And now we do the same for the red line. The red line is a vertical line, so it's going to be one of our special ones also. Again, we ask ourselves, which axis does the red line cross? It crosses the x-axis right there. So it's going to only have x as a variable in its equation. And it crosses x at the value, let's count over here, 1, 2, 3, 4, 5, 6, 7, negative 7. We can see where we're getting this intersection point now, where x is negative 7 and y is 4. A combination of both of these equations here would give us that point. And so looking down our answer choices, we want to find the system of equations that matches those. X equals negative 7 and y equals 4. and that is answer choice C. Question 16, solve the system of equations by the elimination method. So just looking at this system of equations, we can see this is already set up for elimination. We have a positive y and a negative y, so if we just add these equations together, the y's are going to cancel, so that's good. So we have 8x plus a negative 3x would give us 5x. Again, plus y minus y cancels. Negative 5 plus 5 is going to give us 0. And then when we divide both sides by 5, we're going to get x on the left side, and 0 divided by 5 is still 0. Alright, so x is 0, so we'll just plug that back into one of our equations to get y. Maybe we'll pick the first one here. So 8x plus y equals negative 5. X is 0. This becomes 8 times 0 plus y equals negative 5. 8 times 0 is 0, so that really goes away, and really we're just left with y equals negative 5. And it says find the value for y. So our answer for number 16 is B. Question 17. Word problem. School play takes in $3,200 on its opening night. Student tickets sold for $7, adult tickets sold for $12. They tell us the school sold 350 tickets, so we want to know how many of those tickets sold were adult tickets. Okay, so again, let's go ahead and set up this word problem with two equations. Let's look at our total equation like we have been. So our first equation, our total equation. Well, what things are we selling? We're selling adult tickets and we're selling student tickets. So if we're selling adult tickets and student tickets, I'm going to go ahead and just call my variables A and S. And so the amount of tickets that were sold total, it tells us were 350. So we know that adult tickets sold plus student tickets sold gives us 350 tickets. That's our total equation. Now our value equation, so we want to assign values that go along with each of those. So how much is the value of an adult ticket? Adult tickets sold for $12, so that means for every adult ticket we sell, the total amount is going up by $12. So we have 12 times A. And the value that goes with student tickets was $7. So for every student ticket we sell, we get $7, so plus 7s. And then the total brought in is $3,200, so that is our total. And now we have two equations. We have our total equation and our value equation, and this is set up pretty well for elimination. So now we just need to pick a variable to eliminate, and since I could either get a minus 12a here to cancel the a's, or a minus 7s here to cancel the s's. 7 smaller, so I'll use negative 7 here. That might give us a little bit smaller numbers to work with. And let's go ahead and write that down here. So negative 7 times the top equation would give us a negative 7a minus 7s equals negative 7 times 350 is going to give us a minus 2,450 there. Alright, so these are the two equations that we're working with now, down here. And so let's do elimination. 12a minus 7a is going to give us 5a. 7s minus 7s cancels. 3,200 minus 2,450 gives us 750. And now to solve for a, or the adult tickets, the number of adult tickets, we can divide both sides by 5. And so A, the number of adult tickets sold, 750 divided by 5 gives us 150. Okay, and so we want to know, it says how many of those tickets sold were adult tickets. Now we already have that A equals 150. If it was asking for the student tickets, we could go back and use this equation, A plus S equals 350. We could plug in our 150 for A and solve for S. But since we already have what we're looking for, the number of adult tickets was 150, then our answer choice here is B. Question 18 says solve the system by graphing. We have our two equations, y equals 3/4 x y equals negative x plus 7. So if we look at the first one, y equals 3/4 x, we can see this would be the same as y equals 3/4 x plus 0. We're not having anything added or subtracted here on the end. So for the first equation, our y-intercept, our b, is 0, since this is in slope-intercept form. Our b is 0, and our m, or our slope, is equal to 3/4. So we can use that to plot the first line. If we look at the first line, we'll graph the first line in red, maybe. So we can take the first line here, and so we need to go to the y-intercept first and plot the y-intercept, which is at 0. And then we use our slope to get our second point. So from the y-intercept, we need to go up 3 because we have a rise of 3, and over 4, and we get a second point there. So we can see that our line is going to look something like this. And it would go that same amount in the other direction as well. So that's our first line, y equals 3/4 x. And now we want to find our information about our second equation. So we have y equals negative x plus 7. Here our y-intercept, since this is already in slope form, is a positive 7. And our slope, negative x, is the same as negative 1x, so our slope there is negative 1. Let's go ahead and graph this second equation in blue so we can see the difference there. So here we have a y-intercept of 7. So we'll count up 7. 1, 2, 3, 4, 5, 6, 7. So our y-intercept is at that point there. Negative 1 is like a rise of negative 1. So think of the slope negative 1 as negative 1 over 1. So that gives us a rise of down 1 and a run over 1. So down 1 over 1 is going to put us there. And then we can graph that line going through those points. We can see we'll get a line that looks something like that. And so now we look at which system in the choices that matches up best with. And we see here that our point of intersection, first of all, is going to be at, if we look at over 1, 2, 3, 4, and up 1, 2, 3. So this is an x-coordinate of 4. And we can see that this is a y-coordinate of 3. So our intersection point should be 4, 3. If we look at the choices, A through D, we can see that the only one that has an intersection of 4, 3 is choice D. And so we want to just simply take a look and see. So our red line here coincides with the line with the positive slope in choice D going through the origin, and also this line going through has a y-intercept at 7. We can see that both of those lines seem to match answer choice D, and it has the same intersection as answer choice D, so D is our best choice there. Question 19, solve the system of equations. So if we look at this system here, 8x plus 2y equals 1, y equals 2x minus 1, we might notice the second equation here is set up where it's already solved for one of the variables. In other words, this equation is really set up as a y substitution here. In other words, y is the same as 2x minus 1. So the best thing to do is simply use this y substitution, plugging in this information for y into the other equation. So we plug it in, 8x plus 2 times y equals 1 becomes 8x plus 2 times, and then this is the same as y, so that y becomes 2x minus 1. equals 1. And now we distribute our 2, so we have 8x plus 2 times 2x gives us 4x. 2 times negative 1 gives us minus 2, and that equals 1. Combining the like terms, we get 12x minus 2 equals 1. And then we get the x term by itself. We add 2 to both sides. That'll get rid of the subtract 2. 12x equals 3. Then we need to divide both sides by 12. And we get x on the left side, and we get 3 over 12 on the right side, and we can reduce this fraction. Both of those numbers are divisible by 3, so that becomes x equals 1/4. Alright, so we have half of our answer. We have x equals 1/4. Now we can go back to our y substitution equation. It's already solved for y, so it's easy to just plug x in for that there. So let's go ahead and do that. So y equals 2x minus 1 becomes y equals 2 times x. X is 1/4, we said. So 2 times 1/4 minus 1. Here we have, if we want to think of this as 2 over 1 times 1/4 minus 1, then we multiply. Remember, when we multiply fractions, we multiply straight across. So that becomes y equals 2/4 minus 1. 2/4 we can see is going to be the same as 1/2. And a positive 1/2 minus 1 is going to give us that y equals negative 1/2. Alright, so we have the solution. X is 1/4, y is negative 1/2, so we have 1/4 comma negative 1/2. And that's our answer there. And that corresponds to answer choice D. Question 20. Solve the system of equations. Here we can see each equation has some fractions in it, so I think it's going to make it an easier problem to work with if we first clear the fractions out of each equation. So let's look at equation number 1 here. We have 2/5 and 1/4 are our fractions, so we look at the denominators and we say, well, we want to multiply by the least common multiple of the denominators. Denominators 5 and 4, the least common multiple would be 20, so we want to multiply that equation by 20. Second equation, we have denominators 5 and 2, and the least common multiple of 5 and 2 is 10, so we'll multiply equation 2 by 10. Alright, so here we can see we're going to be multiplying this 20 times some fractions, 10 times some fractions. We can think of this as 20 over 1 and 10 over 1 if we want. And so let's multiply this first equation. So first term times 20 over 1, 2 times 20 gives us 40. 5 times 1 gives us 5, and that's our x term there. Next one, minus 1 times 20 on top will give us 20. And 4 times 1 on the bottom will give us 4, and that's our y term. Equals 4 times 20 will just give us 80. And the second equation, times 10 over 1, so negative 3 times 10, that's going to give us a negative 30 on the top. And 5 times 1 would give us 5 on the bottom, and that's our x term. Now here we have a plus. 1 times 10 on top will give us 10. 2 times 1 on bottom will give us 2, and that's our y term there. And on the other side of the equation, negative 7 times 10 gives us negative 70. And so now we can rewrite our equations. We can see that all of our fractions are going to simplify into whole numbers. So our first equation becomes 40 divided by 5 is 8x, minus 20 divided by 4 is 5y, and that equals 80. And our second equation, equation number 2, we have negative 30 divided by 5, that becomes negative 6x, plus 10 divided by 2, which is 5y, equals negative 70. Alright, so now this is set up for just regular elimination or addition method. We can look here, we already have it set up. We have a negative 5y and a positive 5y, so if we just add these together in their current form, we're going to eliminate the y's. 8x minus 6x gives us 2x. Minus 5y plus 5y cancels, and 80 plus a negative 70 is going to give us 10. And now we have 2x equals 10. We just divide both sides by 2, and that gives us our answer for x. X equals 5. And now we can go back and plug into an equation where we can solve for y. If I go back and plug into these original equations here, it's a little bit more complicated because we have the fractions, so I'm going to go ahead and plug x back into one of my equations where we had already cleared our fractions. So I'm going to take this information, maybe we'll just plug it into this new version of equation 1. So there we have 8x minus 5y equals 80. And we said that x was 5, so that becomes 8 times 5 minus 5y equals 80. And then we just take 8 times 5, we get 40 there. 40 minus 5y is 80. And now we get the y term by itself, so we subtract 40 from both sides. And we get that negative 5y equals 40. And now we'll have to divide both sides by that negative 5 there. And we come up with y on the left side equals 40 divided by 5 is 8, and it's a positive divided by a negative, so they're opposite signs, so we get y equals negative 8. And so our solution for the system of equations is going to be 5 for x and negative 8 for y. That's our solution there. And that matches answer choice C.